Hi, this session is on our number revision worksheet. So I'll be going through most of these questions, and if there's anything you're not sure about, please make sure you go to that specific question or watch the whole thing if it helps. Now, question 1 talks about a keyword that you have to remember, which is called irrational. And basically there are two main points that you need to remember that describe an irrational number. The first one, we know an irrational number is infinite. That's another keyword, which means never ending. So it's an infinite decimal with no recurring pattern. And recurring is another keyword that we know means a pattern. So the decimal are just random numbers. And the other important point is it can't be turned into a fraction. Okay, and that's something else you'll see later on in the year. So if we go to question 1, which one best describes an irrational number? The decimal terminates. Well, we know that's wrong because it actually never ends. The decimal never ends and is reoccurring. No, that is wrong because we know there is no pattern. The decimal is infinite with no recurring pattern. So C is the answer for that question. Now, question 2 involves BIDMAS, and we'll be looking at this later on in the next couple of weeks. But when it comes to BIDMAS or BODMAS, we know that brackets comes first and then index numbers or powers. So if I have a look at this, starting off, I can see I've got brackets here, 12 minus 2, so I must do that first. 12 minus 2 is just 10. Now, I'm going to show clear working out so I don't confuse myself. So I've still got 20 plus 5 times, and now there's a 10. So it's nice and clear. Now, the next step is look at your operations. We've got addition here and multiplication. With BODMAS, we know that multiplication comes first. So I have to do 5 times 10 first. So I'm placing in some brackets to remind myself. So 20 plus is still there. And what is 5 times 10? 5 times 10 is 50. So now I have 20 plus 50. And 20 plus 50 is just 70. So that should have been your answer. So question 3 is, what are factors of 15? So I'll just write that one down. Now, if you remember from last year, factors are numbers that divide evenly into a number. And they always pair up with something else. And to start writing, there are a limit of factors. So it's not an infinite amount. It's not like multiples. And the trick is, with factors, always start with 1 because 1 is a factor of every number. It can be divided into every number. And then always have the number itself on the end. Okay, so 1 and 15, it starts from 1 and stops at 15. You can't go past 15 and you can't go below 1. So what are factors that divide into 15 in between 1 and 15? So I'm just going to start with 1, 2. Can 2 go into 15? No. Can 3? Well, 15 divided by 3 is 5. That's its partner, but I'll try 4. Can 4 go into 15? No. So I know 5 can. Can 6 go into 15? No. Can 7? No. And once you've reached halfway of that number, you can stop because it's impossible for the higher numbers to get in there. So I know 8 can't divide into 15, and I'll stop there. So these are the factors of 15. There were 4 factors, and let's see what answer that was for question 3. So I got 1, 3, 5, 15, and it was E, 1, 3, 5, 15. Number 4, what is the square root of 36? So they've written the square root in words, but we know we can write the square root like this. Square root of, what was it, 36? Yeah. And we know we're experts at this now. We know it's a square root because there's an invisible 2 there. And that 2 is asking us, is there a number times itself twice? So twice to give us 36. And we know that 6 times 6 gives us 36. So the answer, the number for this question is 6. Number 5 asks us, what is 4 squared equivalent to? So basically, we know that 4 to the power of 2. Now, be very careful. This is not saying, so not equal to, not saying 4 times 2. A lot of students make that mistake. So that's a big no-no. 4 squared is saying 4 times 4, which is 16. So the answer for that one was D, okay, where you had 16. Whoop, that one there. All right, number 6. So we'll go to number 6. Now this one's pretty straightforward. It's important that we line up everything according to the correct place value, okay? So what I do, I write the first number up here. We are adding, so it doesn't matter if you've got your small number or bigger number on top, but try and write it neatly as possible and leave some space. You can draw some lines, some columns if you are messy. So I might demonstrate that quickly. So now that I've got my columns, I cannot go wrong. Always start, in this case, the lowest number is our ones. We have no decimal that's visible. So 5 goes under 7, then 6, then 5, then 7, then 9. So that was pretty easy. And now we simply have to add them up. So I'll change my color. All right, so 7 plus 5 is 12. Put the 2 down, carry the 1. We've got 1 plus 5 is 6, and 6 plus 6 is 12 as well. So we've got 2 there, carry the 1. 8 plus 1 is 9, and 9 plus 5 is 14. 5 plus 1 is 6, and 6 plus 7 is 13. Put the 3 down, carry the 1. 7 plus 1 is 8, and 8 plus 9 is 17. And we're done. Now, number 7, we are subtracting, and before we subtract, is our answer going to be a positive or a negative? We can see it will be negative because our large number, 879, is first. So larger number minus a small number will give us a positive. Now, when subtracting, we know the larger number must go on top, take away, and this is pretty easy because they all have the same amount of place values. And now we subtract. So 9 take away 3 is 6. 7 take away 2 is 5, and 8 take away 2 is 6. And we're done. So this one had no borrowing, so we may do one later on where it involves borrowing. Okay, next question, multiplication. So when setting up multiplication, try and have your bigger number on top because it's easier to work out. It's structured better. And make sure everything is also lined up in the correct place value. It's important as well. So 2 and 1 are both in the ones column. If you're messy, then do those columns, okay? Including in the answer. Now I can see this one's going to be pretty straightforward because we don't have any tens and so on, so no magic zeros. So let's have a look. 2 times 1 is 2, 2 times 4 is 8, nothing to carry. 2 times 2 is 4, 2 times 3 is 6. And we're done. Okay, with number 9, we have to go 8 divided by 3. Now what I like to do, I like to show this in fraction form. So 8 divided by 3. We know that line there, the vinculum, also means divide. And the reason why I do that is it reminds me that the number 8 will fall down and go under that bridge. Okay? So actually I'll do it down here, so it's a bit more room. So 8 must go under that bridge and 3 on the outside. Now, we know that we have to now add something that's invisible, and that is our decimal point. We can see we will have remainders, and I'm going to add some zeros in case there is a pattern somewhere. All right, and now to do this, can 3 go into 8? Yes, it can. 3, 6, 9, so it can go twice. So 3, 6, and then remainder 2. Can 3 go into 20? I know that 3 times 6 is 18, so it can go 6 times, but I also have remainder 2. And 3 into 20, once again, goes 6 times and remainder 2. 3 into 20, 6 times, remainder 2. I can see this pattern is infinite, it's recurring, and it will never end. So to write our final answer, we have 2.6. 6 is the only number in that pattern, so I'll put a dot on top of that 6. Okay, and that is our final answer. Okay, number 10. So there's number 10. It says convert, and we've got 23 over 3 or 23 divided by 3 to a decimal. That's really easy because all we're doing is dividing those two numbers. So once again, we know 23 will fall down and go under that bridge and 3 on the outside. Now I'll get some zeros ready. This may have a long pattern. That's my feeling, but we'll see. I could be wrong. Okay, can 3 go into 2? No, but can 3 go into 23? Yes. I know that 3 times 7 is 21. Oh, I forgot my decimal up here. Another mistake that I forgot to do. So 21 and remainder 2. Okay. So 7 is my whole number. And let's see. Can 3 go into 20? Yes, it can. It can go 6 times remainder 2. Oh, 3 into 20, 6 times remainder 2. 3 into 20, 6 times remainder 2. And so on. So once again, this has the same recurring pattern as the previous question. The whole number was 7. Don't have to write a 0 there. 0.6 with a dot on top. Nice and easy. Okay, 11 and 12 I'll do together because the question says explain the following keyword. Okay, so terminating and finite. So terminating, if you ever get stuck, think of the Terminator. We probably heard of that movie. And basically the Terminators came to Earth to put an end to the Earth. So terminating means it stops, or in mathematical terms we can say decimal ends or stops. Whatever word you want to use. But just mention that it's a decimal that's stopping. And for example, we can provide an example, 2.5. Decimal stops and we're done. Finite. Finite now is the opposite to infinite, which means it also stops. Okay? So these two words actually mean pretty much the same thing. So once again, we say the decimal ends. And we can use the same example, or a different example might be 0.5. There we go, a half stops. And that's it. Now with number 13, whenever you multiply a number by 1 and zeros, so in this case 100, there's always a shortcut. All we have to do is move the decimal, or in this case add the zeros. So with this one, I've got 2 zeros, so my answer will be 41 and add the 2 zeros. So now it's 4,100 and we're done. Okay, so never set it up like this. We got 100 times 41, and you end up with, 001, and then magic 0, and then 001. I mean, you'll get the right answer, but it's wasting time. Sorry, a bit lagging, but yeah, that's just going to waste all that time. But the other thing that's happening that I want to point out is, if I just change my color, remember there's a decimal point here, and a decimal point, oops, sorry. Imagine I hadn't worked it out yet, so I'll just write this bit out. So what happens is when you've got 2 zeros and we're multiplying, we always move to the right because our number is getting larger. So the decimal point is actually moving. It moves 1, 2 spaces, okay? And we put in zeros in those spaces. So we can rub off that decimal. And we can see how that decimal has moved, okay? And that's nice and easy. Okay, so 14 and 15 involve that same trick, which is all we have to do is move that decimal. Okay, so with the first one, we are multiplying. Check your operation first. Multiplying, we move to the right because our number gets larger. How many times is our decimal moving? 2 times because there's 2 zeros. So I can work it out here, 1, 2, my decimal point goes there. So my answer is now, I've got 6309. Decimal point can be invisible at the end. So my number is 6,309. 15, 15 we're actually dividing. Sorry, I wrote times, so I just changed that. Now, because we're dividing, we have to move the decimal to the left because dividing, our number's getting smaller. Now, how many zeros do we have? I counted 1, 2, 3, 4, 5 zeros. Okay, so our number is 100,000. So we're going to have to move the decimal 5 times to the left. Because I can see I haven't got enough digits to move the decimal, I will have some empty spaces. If you get confused doing it that way, what I'm going to do is add some zeros first. So I might put 2 more zeros there. So 6, 5, 9. There's decimal point and 008. So now I'll move the decimal 5 times. So 1, 2, 3, 4, 5. Decimals now move from there. So my answer is, you can put just point, or you can go 0 point, and then we've got 0, 0, 6, 5, 9, 0, 0, 8. And that is your to be answer. So the trick is, add the zeros first. If you're confident with filling in the spaces, then just do that. Okay, with 16 and 17, you may have forgotten what we mean by multiples. Okay, multiples basically mean it's the answer when you multiply two numbers. Okay, so for example, if I said to you, just to make sure we understand what it means, if I said to you 2 times 3, I know that 2 times 3 is 12. So 12 is a multiple of 2, and it's also a multiple of 3. So it's the answer when we multiply. Or in maths, instead of saying answer when multiplying, we really say product. Okay, so the products. So let's try, we'll do 17 first. Just rub this off. So with 17, it's basically counting by 2s. They're the multiples of 2s. And we have to write the first 20 multiples of 2. So you ready? We've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we keep going, 22, 24. I can't fit it on my page, but you write the first 20. And that's it. And with 13, so 13 is a bit harder because we have to, you may not know your 13 timetables. We have to write down the first 6. And if you have your calculator, you can use it as a tool to help you. So the first one is 13, and then 26. And then what's 13 times 3? We've got 39. So that's a 3 there. Okay, and then what comes next? We've got, so 13 times 4, that's 64. And then 13 times 5, 65. And one more. 13 times 6, we've got 78. And they are the first 6 multiples of 13. Okay, with 18 and 19, we can see we have powers. The first one is just 2 to the power of 6. So remember, do not go 2 times 6. This is saying 2 times 2 times 2 times 2 times 2. Just squeeze it in, times 2 6 times. Okay? So imagine you didn't have a calculator. So we work this out without a calculator. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. Okay? But do put it in your calculator. There should be an x squared button. So you push the number, then push the x squared button. Or in this case, my calculator, there's an x with a box because it's a larger than 2, sorry. So I've got 64. If you're not sure how to put big numbers on your calculator, then let me know. 19, so do I go 4 plus 3 first? No, you always do BIDMAS or BODMAS. So O stands for powers of, and in BIDMAS it stands for index numbers. So first, evaluate your index numbers. Evaluate means show the value. So 4 squared, 4 times 4 is 16, plus 3 squared, 3 times 3 is 9. And then we have 16 plus 9, which gives us 25. And we're done. Now with 20, we're doing the opposite, okay? And it's asking us to simplify 5 times 5 times 5 times 5. Now, this involves an index law, which we'll be learning this year. You may have come across it. But I'll show you the trick. Well, the first thing is we've got 5 being multiplied with itself. So you write 5 as a base number. And how many 5s are there? 1, 2, 3, 4. So there's 5 to the power of 4. And that's been simplified, okay? The question isn't asking us to calculate or evaluate. It's just showing us, it's asking us to simplify. And another way of looking at it is, there's an invisible 1 above every 5. And the first index law is when you multiply the same number, you add those 1s. So 1 plus 1 plus 1 plus 1 is your 4. Okay, if that confused you, don't worry. But I thought I'd just let you know what we're actually doing. And so for 20, you should have had B. Number 21, this is nice and easy. We know a number times itself 3 times to give us 27. Well, 2 times 2 times 2, if I try 2 first, this will give me 8, so that can't work. If I try 3, multiply it 3 times, it gives me 27. So the answer is 3. Now, with 22, it asks us to use a mental strategy to work this question out. So mentally, this is what I'm thinking. I would go do my hundreds first. So I will have 600 plus 2 in the 200 column and do that first. So 600 plus 200 leaves me with 800. Whoop, so I've got 800 sitting there. Okay, and then I'll do my 10. So I've got 40 plus 40. So the other bit I'm thinking of is 40 plus 40. And mentally, I'm thinking that gives me 80. So far, I've got 880. And then do my ones. 3 plus 2. They're in my ones column. And 3 plus 2 is 5. So my answer, mentally, would be 885. If you have a different way, then try it your way. But it's great to be able to calculate questions like these mentally. Now, number 3 is an application, and there are a few skills involved in this question. Let's read the question. Ken went to the fruit market and bought 3 kilos of apples at $1.80 per kilo, 800 grams of peas at $2.90 per kilo, and 1.5 kilos of oranges at 89 cents per kilo. So the trick is everything is being measured in kilos, okay? And we notice that here we have 800 grams. So you'll have to change 800 grams into kilos, okay? And we know there's 1,000 grams in 1 kilo. So try and work out how you'll turn 800 grams into kilos. It will involve a decimal. But let's do the first one. So we've got to multiply basically everything. So we've got 3 kilos of apples. And so times 1.8. So when we're working this out, you can just put this in your calculator, but you don't have to write kilos and things like that, okay? You just write it as simple as possible. 3 times 1.8. Next, we've got 800 grams. So 800 grams is written as 0.8, you can say 0.800 or just 0.8 kilos. So that's what you should have had. And if you have forgotten this, that's okay. So 0.8, and we've got 2.9. So times that in your calculator. And the next one is 1.5 times 0.89 or 0.89. So multiply these, and then of course you have to add the total together. So use your calculator for this one. So grab your calculators. All right, so 3, oops, that didn't work. All right, 3 times 1.8. And then you can push equals, but I'm just going to push plus. 0.8, so 0.8 kilos. Remember, we changed 800 grams to kilos. Times 2.9. You can put 2.90, but you don't have to. And then plus 1.5 times 0.89. And our answer, oops, sorry. I'll put plus 0 because I accidentally pushed plus, and I don't know how to delete that without starting again. So equals, we've got 9.055. Now, we can see that because we are now working with dollars and cents, we have to round off this to the nearest hundredth, okay? So if we have a look at our answers, the closest one here, we've got 9.0 or $9.06, okay? So if we round this one off, we end up with $9.06. So your answer should have been E. Okay, so question 24 says, write down 4 decimal numbers in between 5 and 6. And another way of figuring out how many decimals or what kind of decimals I can write, this is what I do. I write 5.00. You can actually add as many zeros as you want, but I'll just do 3. And then I need to get to 6.000. So look at it as though it's, imagine there was no decimal point. We would have 5,000 and 6,000. So to get to 5,000 and 6,000, what numbers do I have in between? Okay, that's a way of looking at it. So what I mean is, for example, I can have 5,100, but don't forget the decimal point is really there. Or I can have 5,200, 5,300, all the way to 6,000. Okay, or you could have even less than that. You can have 5 point, just say 1 and 5.2 and 5.3. So depending on how many zeros you put, you can be getting between, just say you had 2 zeros, how many places in between 500 and 600? That's a way of looking at it. So whatever you had, as long as it was in between 5 and 6, then you're correct. Okay, this is the last question for this session. 25 says 0.006 times negative 0.2. Sorry, I just squeezed it in. It looks a bit messy. Okay, so first step is we've got a negative. So, and whenever you are multiplying negatives and positives, your first step is your answer going to be a negative or a positive? Okay, I've got one negative in the whole thing. Because it's an odd amount, my answer is going to be negative. That's the first thing. That's taken care of. And now all we have to do is multiply these two numbers. Now, we do have decimals, which can confuse you. But the first step is, if you remember the other lesson we watched, ignore your decimals. Which means, if you're not sure what that means, if I didn't have a decimal there or a decimal there, I would have 0.006. Now, what number is that? That is just 6. So I have 6 times, and if I didn't have a 0 here, I'd just have 2. What is 6 times 2? Well, 6 times 2 is 12. That's easy. Don't even need working out. But of course, we haven't stopped there. We can't just stop there. The next step is go back to the question, or the two numbers you're multiplying. So the decimal was there, and it was also there, 0.2. And count how many decimal places are there in total. So here I've got 1, 2, 3 decimal places. So 3 numbers after the decimal. And here I had 1 number after the decimal. So in total, there were 4 decimal places. So 4 decimal places, which means I now have to move the decimal in my answer. So if I go to my 12, where is the decimal right now? It is here. And I have to bring it back 4 times to get the final answer. Okay, so if I rub off my equal signs, I'm going to add some zeros just to save me not getting confused. And I have to bring it back 4 times. You ready? 1, 2, 3, 4. That's its new place. So I know my answer was a negative, so minus 0.0012. And that is the answer.